So basically what we are going to do in today's lecture is the third isomorphism theorem. Okay. So G upon n upon m upon n is isomorphic to G upon m. That is what we are going to prove in today's lecture. Okay. So let us start. Third isomorphism theorem. So what we are going to do is we are going to do this third isomorphism theorem today. Okay. So the statement of the third isomorphism theorem is if m comma n, okay, like if m and n is normal in G, if this m and n is normal in G and n is less than m, that is n is a subgroup of m, okay, then G upon n upon m upon n is isomorphic to G upon m. Okay, this is what we are going to prove in this. Okay, we have to prove this theorem. Okay, this third isomorphism theorem we have to prove. Okay, this is the statement. Okay, and we need to prove this, that this is isomorphic to this. So let me start with the proof. Okay, now since m comma n is normal in G and n is a subgroup of m, we are going to define G upon n and m upon n comma G upon m. So what we have to do is now define an onto map. Okay, that is f from G upon n tending to G upon m such that f of Gn where Gm. Okay, so now what we have to do is, now to check if f is well defined, now we have to see if f is well defined. Okay, and this is the condition which is given to you all. Okay, that is f of Gn is equal to Gm. Okay, now let us see. Now f is well defined. Now G1 of n is equal to G2 of n. Okay, now this implies that G1 inverse G2 belongs to n since n is a subgroup of m. Okay, now G1 inverse into G2 belongs to m, then G1 m is equal to G2 m. Now what was the condition? G m is equal to f of Gn, right? So f of G1 of n is equal to f of G2 of n. So from this we can see that f is well defined. Okay, we can see that f is well defined. So moving towards the next part, that is now we have by fundamental theorem of homomorphism. Okay, now we have to see by fundamental theorem of homomorphism G upon n upon kernel of f is isomorphic to f of G upon n. Okay, so now since f is onto, okay, now we have to show that f is onto basically. Okay, so let us show that f is onto. For that, what is the statement? For any y belonging to G upon m, there exists Gn belonging to G upon n such that f of Gn is equal to y. This is the statement. Okay, now we have to, taking this, we have to prove that f is onto. Okay, now Gm is equal to G dash of m. Now this implies that G dash into G inverse into G dash belongs to m. It implies G dash belongs to Gm. Okay, so what I have done over here is I have taken G inverse to the other side, so it will become positive, right? The inverse will go. Now G dash is equal to Gm, small gm, for some small m belonging to capital M. Okay, so now this implies that this G is equal to G dash m inverse. I have taken this m to the other side, so it will become m inverse. Now this implies that f is onto. Okay, now image of group is equal to codomain, that is f of G upon n is equal to G upon m. Okay, now so G upon n upon kernel of f is isomorphic to G upon m and take this as equation 1. So we have to show that kernel of f is equal to m upon n. Okay, now we have to show that kernel of f is equal to m upon n. So in place of kernel of f, what we need is m upon n. Okay, now we have to show that. So now to xn, now to show that kernel of f is equal to m upon m, let us take an element xn belongs to kernel of f. Okay, now this implies that f of xn is equal to m. Now xm is equal to m. xm is equal to m. Now this implies that x belongs to m. Now xn belongs to, now this implies what? Xn belongs to m upon n. Therefore, now this xn is belonging to what we have done is, wait. Okay. Now this xn, it belongs to kernel of f. So in place of xn, I am going to write kernel of f over here, okay, which is equal to mn. So therefore kernel of f is equal to m upon n. Okay, so this was m upon n. So now using in 1, so we are putting this value of kernel of f is equal to m upon m. We are plugging this value in equation 1. Okay, so what is your equation 1 over here? Okay, g upon n, in place of kernel of f, I am plugging m upon n. Okay, is isomorphic to g upon m. Write it as it is. Okay, this part. In place of kernel of f, I am writing what? M upon n. Okay, so finally we have proved the third isomorphism theorem. Okay, I hope you all have understood this, and thanks for watching.